Good morning. My name is Professor Shannon Gracie, and today we'll be working on section 7.2 from Robert Blitzer's Introductory and Intermediate Algebra for college students. So here we go. Today we'll be working on multiplying and dividing rational expressions. So let's go ahead and get warmed up. Remember, the instructions are to simplify. All right. So let's see how you do. Remember, how do we start out doing this? It starts with an F. It's not a bad word. Good. Factoring. Right. Pause the movie. See how you do. Okay. So let's take a look at part A. Depending on how you work this, if you recognize that this was a perfect square trinomial, that's awesome. Otherwise, you would have done your x, and you would have had an overall product of +1. And so that -2 will be the result of adding two negatives. And so the two numbers that fit that bill are -1 and -1. So then we would have a squared minus 1ab minus 1ab plus b squared. And then what do we have going on in the denominator? Very good, we have a difference of squares. So that will factor as a plus b times a minus b. So here we go. This denominator is completely factored. We're still working on this guy. So here, this is like, our red group and our blue group like we've done before. So when I factor our red group, we'll have, I can factor out an a. We'll be left with a minus b. And if I factor out a negative b, we'll be left with an a minus a b. And that's all over a plus b times a minus b. So far, this is equivalent to this, which is equivalent to this. And of course, the green is still the same. So then we will end up with, I can factor out an a minus b from the numerator, and then I'm left with an a minus b, and that's over a plus b times a minus b. So this is the factorization of the numerator, and then we still have this guy here as the way the denominator factors. Now notice that we have one factor of a minus b that we can divide out, and then we're left with a minus b over a plus b. Now, we're done. Don't go crazy and start crossing out those a's and those b's. We're all set. Okay? Half the battle in these rational expressions is understanding when you're done, when you should stop. Okay, so here we go. Factoring the next one. Our x will be, we'll have a +2, and we have a -3 and that'll be the result of a sum of two negatives. So let's see what fits the bill, -1 and -2. So factoring, we will have x squared minus 1x minus 2x plus 2 over x minus 1, which is prime. Then, working on the red group and blue group, we will have, and by the way, this guy is equivalent to this. And we'll have, we can factor out an x, we're left with x minus 1. If we factor out a -2, we're left with x minus 1. That's all over x minus 1. And to complete the factorization of our yellow group, we'll get x minus 1 times x minus 2, and that's over x minus 1. All right, I'll go ahead and we can put parentheses around that quantity, that complete quantity that's in the denominator, and can divide out those x minus 1s, and we are left with x minus 2 over 1, which is just x minus 2. How'd you do on the warm-ups? Awesome. Okay, so let's see what we're going to be talking about today. Here we go. If P, Q, R, and S are polynomials where Q is not equal to 0 and S is not equal to 0, then P over Q times R over S, just like with regular fractions, ends up being P times R over Q times S. And then once you've made it one happy fraction, you go about simplifying like we did in 7-1. All right? So in words, the product of two rational expressions is the product of their numerators divided by the product of their denominators. All right. So here's some steps for you. Very first one starts with an F. It's not a bad word. You got it. Factor all numerators and denominators. Okay. And remember, these steps are when you're multiplying. Right? Divide numerators, and denominators by common factors, and then multiply the remaining factors in the denominator. Oh, sorry about that. Ahead of myself here. Multiply the remaining factors in the numerators and multiply the remaining factors in the denominators. Okay. Now, I like to actually get one happy fraction right off the bat. So, the way I do it might be a wee bit different than the steps given. But it all, amounts to the same thing. So here we go. Part A, one thing that you might want to do is just put parentheses around this stuff. Okay? Around the numerators and the denominators. Remember, we can't put parentheses. It doesn't make any sense to put parentheses around like the x alone, and keeping that minus in the middle. That won't help us here. So this is going to give us one happy fraction of, I'll put the x minus 5 times the 18, and that's all divided by the 3 times the x minus 8. Now, what we need to look for is there anything that has common factors, right? So here, the x minus 5 and the x minus 8 we can't do anything with. But notice that we could rewrite that 18 as 3 times 6, couldn't we? And then we have this 3 down here that we can divide out. So this 3 divides out that 3. So at the end of the day, if we commute the constant, we'll have 6 times x minus 5 all over x minus 8, and we're done. All right? Okay, pause the movie and you guys try part B. And if you feel really brave, you can go ahead and do C and D as well. Okay, let's see how you did in part B. So here, we've got making one happy fraction. We've got x times 30 over 5 times x minus 4. Now, we could write that 30 as 5 times 6. Some of you guys might be comfortable with saying, oh, 5 goes into itself once and into 30 6 times. So now we'll be left with 6 times x over x minus 4. And you're all done, because that subtraction symbol means we can't cross out those x's. Okay, they have to be factors. The 6 and the x are factors, but in the denominator, there's only one factor, and that factor is x minus 4. So you're all set. All right, so if you haven't tried already, you can try C and D. Right? If you feel like you need an example with C, I'll go ahead and work it right now. Otherwise, pause the movie and go ahead and do it on your own. Okay, so first off, I want to get one happy fraction, so I'm going to multiply the numerators and the denominators. But I'm going to go ahead and start factoring them as I do this. So notice that we can factor out a 3 from that first numerator, and we're left with 3y plus 7. So this is equivalent to all this times y minus 2. It's already prime. I'll just put parentheses around it so that we keep true to multiplying this 9y plus 21 times the factor y minus 2. Okay, the first denominator factors is y times y minus 2. And then we still have the 3y plus 7 is prime. So this is equivalent to this. Okay, now I put everything, all the factors are in parentheses. So are there any parentheses? Exactly the same. Good. We have one factor of 3y plus 7 in the numerator and denominator. And we've got one factor of y minus 2. So at the end of the day, 3 times 1 times 1 is 3. Y times 1 times 1 is y. So we get 3 over y. Okay, so now let's take a look at part D. I'm going to go a little bit more quickly in the factoring. Okay, I'm going to factor by trial and error. If you need to do the x's, that's fine. The first numerator factors as x plus 2 times x plus 3. The second numerator is a difference of squares, so we'll get x plus 3 times x minus 3. It's going to be all over, so let's match up what we've done so far. This guy factors as this. And this guy factors as this. And then the first denominator will factor as x plus 3 times x minus 2. And then the last denominator, the second denominator, will factor as x minus 3 times x plus 2. Alright, and let's see, we'll get a different color. There we go. Okay, so now let's see. Now we can have a dividing out bonanza. So I've got 1 factor of x plus 2 that I can divide out. I can divide out 1 factor of x plus 3. I can divide out 1 factor of x minus 3. And that's it. So we will get an end result. 1 times x plus 3 times 1 is x plus 3. And then 1 times x minus 2 times 1 is x minus 2. Stop there because these are both prime polynomials. We can't divide anything out. Okay? All right. How'd you do? Awesome. Okay, so now dividing fractions. You know, you just have a little bit more complicated of a fraction. So here we are. If P, Q, R, and S are polynomials where Q is not equal to 0 and R is not equal to 0 and S is not equal to 0, then if we have P over Q divided by R over S, remember that turns into a multiplication problem. P over Q times S over R. And didn't we just talk about what that was? That would just be P times S divided by Q times R. So as soon as you invert and multiply, it turns into a problem just like we were working on in the last example. So in words, the quotient of two rational expressions is the product of the first expression and the reciprocal of the second. So here we go. Example 2, divide. So, following our rules, we rewrite this as x over 3. Now we want to change that to times, but nothing in math is free, right? So we need to invert and multiply. Then this becomes, x times 8 over 3 times 3. And then we'll get 8x divided by 9, and we're done. Okay, so if you would like, go ahead and pause the movie and give B, C, and D a try. And then we will go from there. Okay, let's see how you did. We have this one, we've got x plus 5 over 7. We're going to change that to times the reciprocal, which will be 9 over 4x plus 20. Now it turns into our multiplication problem. So we're going to have x plus 5 times 9 all over 7 times. I can factor out a 4, and I'm left with x plus 5. So what I needed to factor was the 4x plus 20, and that's how it factored. Looking for common factors, I've got a factor of x plus 5 I can divide out, and then I have no other common factors, so multiplying 1 times 9 is 9, and then 7 times 4 times 1 is 28, and we're all done. How'd you do on that one? Great. Okay, part C. Here we go. This will give us y squared minus 2y over 15 times 5 over y minus 2. We will have y times y minus 2 times 5. So the y squared minus 2y factors like that. And that's all over 15 times y minus 2. So we've got the factor of y minus 2 that can be divided out. The 5 goes into itself once and into 15 3 times. So our end result will be y times 1 is y over 3 times 1 is 3. And we're all set. All right, next one. Here we go. Difference of squares. So this first, I'm going to start factoring. Well, I think I'll have room. We'll factor on the next step. First, we'll show the division step. So this will be times x plus y over x squared minus 4xy plus 4y squared. So now factoring. This will factor as x plus 2y times x minus 2y. That's our first numerator. Our next numerator is x plus y. It's already prime. The first denominator will factor as x plus 2y times x plus y. That will give us a sum of 3xy in the middle. So this is equivalent to this. And then the second denominator will factor as x minus 2y, the quantity squared. It's one of those perfect square trinomials. All right, so here we go. We've got x plus 2y divides out. The x plus y's divide out. We have one of these, so it will divide out one of those. So we'll have an x. Actually, let me do that a little differently. This will be left with an x minus 2y, one factor of it. So at the end of the day, 1 times 1 times 1 is 1 over 1 times x minus 2y is x minus 2y, and we're all done with that guy. How'd you do? Did you get that one right? Awesome. All right. Now here we go. These guys, they're going to be just a little bit more challenging. All right, so don't forget about your order of operations. I would highly recommend with part E that you do what's in the parentheses first, and then once you have one happy fraction, you can do the division portion of it. So this is 5x squared minus x over 3x plus 2 divided by. So factoring, we will have the 6x squared plus x minus 2. Let's go ahead and come down here. Okay, overall product of negative 12. And we'll have a middle term of positive 1. So the two that fit that bill will be negative 3 and positive 4. So coming over here, I'm gonna make this a little bit smaller. Okay, so we'll have our 6x squared minus 3x's plus 4x's minus 2. Times Well, I'm going to keep them as separate fractions for the moment just to make it easier. So that'll be over. Now the second x. So far I've done this work on this guy. Okay. Now the second one I'm working on here is this guy. Okay. And so our x for that guy is going to be overall product of negative 10, which means we need to end up with a difference of positive 1, or I apologize, positive 3. So 5 and 2 fit the bill. So it'll be a negative 2 and a positive 5. All right, so we will have 10x squared minus 2x's plus 5x's minus 1 times. Now these are not going to be as difficult. I can go ahead and factor these guys. So we'll have a 2x and an x. And we need to have a minus x. So I believe our minus 1 will be here and our plus 1 will be here. Let's see if that works. Yes. So then over, we can factor out an x and we get 2x minus 1. And let's just show how these match up. So this guy is equivalent to the blue there. And then this guy is equivalent to this. And then I'll do this guy here is equivalent to this. Okay, so continuing, we will have (5x squared minus x over 3x plus 2) divided by. We can factor out, so here we'll have, these are, the red groups and the blue groups. So we're still factoring by grouping on that first one. So I can factor out a 3x and I'm left with 2x minus 1. I can factor out a positive 2 and I'm left with 2x minus 1. I still have times 2x plus 1 times x minus 1 hanging out. And we'll still have an x times a 2x minus 1 hanging out there. All right, so that's the yellow. We have one more step on the yellow, then it's factored. The blue, I can factor out a 2x, and I'm left with 5x minus 1. And if I factor out a 1, I'm left with my 5x minus 1. So this is the continuation of the blue. And then the green and the kind of peach color are good. So then we will have 5x squared minus x over 3x plus 2 divided by. Now we can make one happy fraction. We're going to have, if we factor out a 2x minus 1 from the yellow, we're left with 3x plus 2. And then we can multiply it to the 2x plus 1 and the x minus 1. It'll be all over 5x minus 1 times 2x plus 1 times x times 2x minus 1. So this is the completed factorization of the yellow and of the blue. Okay, let's see if we can divide any of that out. I've got one factor of 2x minus 1 I can divide out. And I have a factor of 2x plus 1 I can divide out. And so far that's it. So continuing, I will now factor. So I can factor out an x. I'm left with 5x minus 1 over 3x plus 2. I am going to multiply by the reciprocal. So the old denominator, 5x minus 1 times x times 1, gives me x times 5x minus 1 over my old numerator, which is 1 times 3x plus 2 times x plus 1, x minus 1. So this is what we will get. So then, it's all being multiplied. So here we go. It looks like we can divide out. Oops, almost made up my own math there. We can divide out. Ooh, they were setting us up here to divide stuff out we're not allowed to divide out. So our end result is going to be, we have x times x is, well, I'm going to just do it vertically. Here we go. So we're going to get x squared times 5x minus 1, the quantity squared, over 3x plus 2, the quantity squared, times x minus 1, and we're all done. And you guys just realize that's really a hard problem. Okay. That's kind of above and beyond the Call of Duty, really. All right, so here we go. I think on this one I will start factoring right off. We'll factor this guy by grouping. Here's our red group and blue group. And some of the other ones will be some special factorizations. So if I factor out a y, I'm left with 5x minus a. And then if I factor out a minus b, I'm left with 5x minus a over difference of squares here. So I'll have a 5x plus a times a 5x minus a. So far, here's the yellow. Here is the blue, right? And then I need to invert and multiply. So I'm going to go ahead and factor out, well, I'll just invert and multiply. So 15x plus 3a over y cubed minus b cubed. Okay, so continuing the factoring, I'll have a 5x minus a times y minus b over 5x plus a times 5x minus a. Then I'm factoring the next one. I can factor out a 3, and I'm left with 5x plus a. So this is the completion of the yellow. This is still the blue. And then this guy factors like this. And then now I've got that difference of cubes, which remember I told you you're not responsible for on the exam. So we'll end up with y squared plus y times b plus b squared. So this here factors like this. And then let's see what we can divide out. We have one factor, I don't like how that, we have one factor of 5x minus a. We have one factor of y minus b. We have one factor of 5x plus a. And I think that's it. So at the end of the day, we will get 3 in the numerator, and we will get y squared plus y times b plus b squared in the denominator. And we're all done. And guess what? We are all done with this section. So we only have one more section to go, and we'll be done with the material for the introductory algebra. So have a fabulous day.